Welcome to another puzzle time with MoMath and MathPickle.
Hello.
Gord, and I see somebody new. So Colin, the way that we introduce ourselves here is that we tell why you insist on using pickle shampoo every day, and why you have you have giant pickles all the time for breakfast, lunch, and supper.
Actually, I was here last week.
Oh, you were, Colin. Oh, sorry. I didn't see you. Okay, anyway, or I forgot. Sorry. Okay, so we today are doing Aesop's Urns. And here we go. We get to add, and Colin, because I made a mistake, you get to go first. You get to say how many of these pebbles you want to add, or maybe they're cherries. I don't know. We'll make them pebbles, red pebbles. How many pebbles you'd like to add, and make it a smallish number. Not super big.
7.
Okay. So here we go. There. Okay. So I have 7 pebbles, and do you know what happens? Well, what happens is Ruta. So you can either guess, or you can, or I will tell you what happens. So,
Can you tell me?
yeah, and I can just tell you what happens if you want. So this is kind of, this isn't a mini mathematical universe, but I will treat it as one. So just for the first 5 minutes. So you guys have to try to guess what's going on here. So you can guess if you want what happens next. Otherwise, I'm just going to tell you. Ruta, you're up. Do you want to guess, or do you want me to just show?
I'm just gonna guess and say 3.
Yep, you're right. 3 goes over here. Exactly right. Yep. Okay, Seth, do you want to guess what happens next, or do you want me to tell you what happens next?
I'm just gonna guess that one shall go into the next one.
And you are wrong. So we have 1 correct and 1 wrong. And this is what happens. Here we go. And you get that. Okay. Oscar, do you want to guess, or do you want me to tell you what happens next?
Well, I'm going to guess that something will move into that either one will move into the second urn, or something will move into the third urn.
Okay. And you are wrong. Instead, this happens. Okay.
But I guessed that something would move into the third urn.
Okay. Rohan, go ahead. What do you think happens now?
I think you need to move one. I think you need to move one dot from one to the other.
Okay, and you're wrong. Nothing happens. That's finished. We're finished with 7. So Colin chose 7, and this is where we ended up with 2 in the first, 3 in the second, 2 in the last one. Okay, Super Kitty Cat, it's your turn. Choose a number, any number that you wish to of pebbles to put in the first pot. Not super big.
7. 7's not too big. I mean, it's kind of big, but
this is what we started with. We started with 7. I don't want to do 7 again.
Well, how about then 5?
5, okay.
I thought we started with 5 for some reason.
Okay, here we go. So
5.
5.
Delicious.
And Amelia, what do you think is going to happen now? And you can just say, I have no idea, and I'll just tell you.
I honestly have no idea, but
He's going to move some dots. Where is he going to move them from? Where is he going to move them to? If you're good, how many?
Well, I feel like you're gonna move. Okay, I'm certain they're gonna move some dots to
Yes.
one of the other urns.
Yes, you are right. I am moving 2 dots and I am moving them over here. And stick person, you have an idea because I saw you circling 2. Was that just pure luck or did you have an idea about what's going to happen now?
I was thinking maybe when something sticks up, then the amount that's sticking up plus the amount plus an equal amount under it goes to the next cup.
Okay, so here we have this one sticking up, but we also have this one sticking up. So what do you think is going to happen here? These 2? Okay, and you're wrong. It's just one of these goes over here. Okay, and next we're going to go to let's go to Solly. Solly, do you think we're finished or do you think that there's something more to happen?
I think 1 from the 3 is going to move to the 2. I mean the last one.
1 from the 3 is going to move to the
last one.
To the left, this way?
To the right.
Okay, to the right. Yeah, you're right. That is exactly
I think I know what's happening.
Well, what do you think's happening?
So can you go back to the beginning? I think I know.
Okay, this is the 5, and then we go here,
So,
here, and here. And,
so back to the beginning.
5.
You split it almost evenly, but the lesser half moved, just as
Yeah.
with 7, 3 moved.
Yeah,
And then the one that has more moves 1 to the last one, or the one that doesn't have
Yeah.
it,
yeah,
or the next one. And then that happens again.
right, okay.
So they have
So,
around equal.
okay, so we are finished with 2, oh, not 3, 2, 2, 1. Okay, done. Okay, so Arohan, it's your turn now. You can choose a slightly bigger number. Let's make it like 25 or under. And I want you to try to make it so that maybe actually we'll use more. Maybe we'll use a lot more.
13.
13? 13 coming up. Okay, so actually I'm going to do that and I'm just going to remove some. Here we go. I'm going to take away, that is 15. And so that is going to be 13. Okay. So Arohan, what do you think is going to happen? Everyone can take 17.5 seconds and figure out what you think is going to happen the next few turns. Okay, Rohan, go ahead. What do you think happens first?
I think 7 of them are going to move to the second urn.
7, and it is actually 6.
Oh, okay.
Yeah.
I think if it's an odd number, it's always split that the ones of less, or the less amount of half moves to the next one.
Okay. So that's Solly's hypothesis, is that if it's an
I
odd
agree.
number splitting, then it's less. The lesser amount does the moving. Seth, you go ahead. So stick person is suggesting we go like this.
I think why not?
You're breaking
Yeah.
up, Seth.
Oh wait, can you hear me better now?
Yes.
Okay, yeah, sure. Just move 1 over. I don't know.
One over.
Yep.
Like this?
Yep.
Okay. And no, that's not right. We are going to move 3 over. So it's like
That's because it's an odd number, and 3 is the lesser amount.
Go ahead,
Of
Oscar.
4 and 3.
Okay, Oscar, you're up. What happens now?
I'm guessing that some marbles from the second urn will move to the third, and I think there will be 4 of them.
Yeah, you're right. That's right. So following the idea here that you are moving about the same amount as is left, but a little bit less if it's an odd number. So yeah, that's exactly right. That's exactly what happens.
Now we have 4, 5, and 4. I'm wondering what'll come next since we have 6 urns instead of just 3.
Colin, what do you think happens now?
Maybe moving some of the 2 from the second one that are remaining.
Yeah, that's exactly what happens. 2 moves over, and you're exactly right. So tell me, who wants to tell me all of the rules now? And specifically, let's do this last one here. Go ahead, Amelia. What do you think happens now?
I had to help my siblings, so I missed a little bit of it, but
so yeah, let's have someone say all of the rules that we've discovered so far. Oscar, do you want to say all of the rules? Yeah.
Here's what I think the full set of rules is.
Yeah.
I'm just guessing. There might be more.
Okay.
When you have, see, at each step, the lower, see, you take half of the leftmost urn that has an odd number of marbles in it. So, and it has to be lower. So if you have 3, then you'll take 1 of them.
Okay, so this is the next move.
And move it to the next urn.
Okay.
And
so
you'll never move half of.
Okay, so this is not right. This is not the,
when there are marbles in all 6 urns.
okay, so this is not a rule. You don't choose the urn with the closest to the left with the odd number. That's not how you select an urn. Super Kitty Cat, do you have any idea about how we are selecting the urn?
I've got a question. Is the rule when you always take half of it and move it to the next urn, right?
So yeah, there's definitely about moving it to the right and definitely about taking half of it. And if it's an odd number, then you just take a little bit less than half of it. That's right. Super Kitty Cat, how do we choose our urn?
We have a poll.
Okay.
Yes.
Super Kitty Cat, just hold on. Don't answer yet. We're going to answer the poll first, and then we'll come back and I'll talk to you about what you think is how you're selecting that urn. Because Oscar's right. Once the urn's selected, you're taking half of it and moving it 1 step to the 1 urn to the right. That's exactly right. But I want to know how you're choosing that urn. Okay, so let's get rid of that. Stop the sharing. If you guys can get rid of the poll. Okay. Super Kitty Cat. Go ahead. Oscar. Yeah, anyway, Super Kitty Cat, you're up.
I'm thinking, okay, so What number did we originate with?
This time we went from 13, then we went to 7, 6, and then we went to 4, 9, and then we went to 4, 5, 4, and then we went to 4, 3, 6, and that's where we are now.
4, 3, 6.
Yeah.
I'm not sure if there's like really a pattern there, so I don't really have anything to say.
Okay, Colin.
I don't know.
Colin, you're up.
So you take from the starting point, you take the less than half part if it's uneven.
Yep.
And you move it to the next one.
Yep.
And take the less than half side of that, add it to the second one. And then from there, it's basically just taking the less than half side from the highest urn.
Okay, so you're agreeing with Taco Cat that how you select the urn, you choose the urn with the most pebbles in it. And that is correct. That is exactly how we are choosing the urn. We're choosing the urn that has the most pebbles in it. So here we have an urn with 6 pebbles. So we're going to be moving that over here like this. Okay. Where do we go from here?
If you're
Solid.
choosing the urn that has the most marbles, what if, like right now, it's a tie between some urns, like the 3 threes?
Yeah. So Solly, what do you think happens? Oscar's saying that it's a tie here.
It isn't actually a tie, but I'm just wondering what would happen if it actually is a tie.
Okay, good. So just asking if what happens if it is a tie. So Solly, what do you think happens here?
Here, I believe the 4 moves 1 to the last one.
Which one moves 1?
The one with 4 in it.
Moves 1 over here?
Yeah.
Okay. And you have to follow the rule about taking half. So
Oh yeah, so 2 over.
Yeah. That's right. So you're going to be taking 2 of these. Okay, stick person. You can take a turn now. What do you want to do now, stick person? Go ahead, stick person, you're up. You want 2 from here over to here, and you're correct. Yeah. Go again, stick person. What do you want to do now? 2 again from here and over here. So yeah, absolutely. You've definitely got the algorithm now. And then 2 from here over to here. Done. And now, stick person, what do you do?
Now it's a tie.
Now it's a tie. So what happens? Stick person or a Rohan, 2 from here over to here. Okay. And that is wrong, stick person. So from here, a Rohan, do you have any idea what to do now?
I think it's finished now.
Correct. It's finished. So that is how you decide whether it's finished, is if you cannot choose an urn that has the most.
Wait.
And in this case, you cannot choose the urn that has the most because there's 3 urns that have the most. Exactly right. That is when you finish.
But on 7 you said that it's the end when, and we could choose. When it was 2, 3, 2, we could choose the urn with 3.
Let's see. So here's
So
7.
let's see.
Then we went like this. Then we went like that. Then we went like this. And oh, you're right. You're right. Oscar, thank you. We hadn't finished. You're exactly right. We had not finished yet. So
we can move for 1, but then we're stuck. The last one, the urn with the biggest amount doesn't have something to the right of it, and then the other 2 it's a tie on.
So I have to add another urn because you're totally right, Oscar. Yeah. So here what happens? This one goes off the page and goes on to the next urn. So yeah, absolutely, I was totally wrong. So the 7, if we want to just choose 7 here. So this here, this here. So that's 7, and let's just do it quickly on this. So you can't do it on that small one. So first of all, we move 3 like this. Next, we move 2 like this. Next, we move 2 like this. Thank you, stick person. Okay. And next, we move 1 over here. And next, we move 1 over here. And now we are finished.
And it's a tie.
Now it's a tie. Oops, 2, 2, 2, 1. Exactly right. Good. Okay. So whew, I'm glad you had that memory, Oscar, because otherwise I would have gone, oopsie, oopsie. Yeah, absolutely. So this is how you finish off 7. Exactly like that. Good. Okay. So your job, you guys, is I'm going to let you into this presentation, and I want you to tell me the first number that requires you, the smallest number that requires you to fill up all 6 urns. And I'm also interested in just any patterns that you guys discover here. So I'm not going to share the presentation, and here we go. And copy link. And let's add that. Colin, go ahead.
The smallest number is 6.
That fills up everything. Okay, let's look at that. Okay, so I'm just, you guys will not be able to edit this document. So instead you can go in and you can copy it. And Super Kitty Cat, if you can give your spiel here about if I go into here and do make a copy entire presentation, does that always work for everybody, Super Kitty Cat?
No, only with people that are logged into a Gmail.
Thank you.
You could go to the download instead.
Okay. Right. So just here. Right.
Never mind, it doesn't work.
Okay. So Colin, you were thinking about 6. Why doesn't it work? I'm happy to go through it. Okay, let me just go through it. Okay, so here we go. So you start off with 6, and then what happens next? We take 3 of these, we move it over here, and what happens then?
Nothing.
It's a tie. Nothing happens. It's a tie. So 6 ends off really quickly. So I'm looking for any patterns that you guys discover, and I'm specifically looking for the smallest number that fills all 6 of these urns. Okay. So those of you who are with me, I am going to, or those of you who are off exploring by yourself, we have a new mechanism now to indicate that you don't want to be interrupted. And that mechanism is that you go down to your, let's just see, you go down to your reactions.
Is it this little
Zoom
coffee cup I have?
And that's right, it's the coffee cup. So if you put the coffee cup, it says, I'm away. And that is going to indicate to everybody that you do not want to be disturbed by me because you are thinking your own thoughts, and that is cool. I will not interrupt you. Good. Until I call you back, and then I'm going to interrupt you a lot. And so I will call people who decide to go off and explore and try to find some patterns here. I will invite you back in 12 minutes. So that will be our time to reconvene. If you're with me, then we're just going to go at a relaxed pace, and you guys are going to tell me what I should do here. So Super Kitty Cat, Oscar, Daniel, Taco Cat, and Ruta. Ruta, you're up. What would you like to experiment with? What number would you like to experiment with?
I'm gonna try 20.
Okay. So there is 20. And Ruta, what do you think is going to happen? Think ahead a few moves, and what do you think is going to happen with 20? Do you have any insight about how this, I guess this is a crow moving the pebbles from urn to urn. Do you have any insight about what might happen?
Maybe a 10.
Yeah, for sure. A 10 is going to move over here. And what's going to happen now?
A 5.
No, it's a tie. You can't choose an urn. The selection of an urn, you're always going to be looking for the urn that has the most pebbles in it. So here, this one stops. 20 stops immediately. So it's not that it doesn't work, stick person. It still works. It just is very fast. You come to an answer really quickly. But this is still a good answer. Okay. So I would like you to stick person. I'd like you to go away, and I'd like you to work on some big patterns. So don't interrupt us here. We're going to be working on other stuff, and you go and find some big patterns. I can see that you're away now, so that's good. That's good. Okay. Let's go. Oscar, do you have any ideas about what you would like to experiment with? Oh, sorry, I do want to.
The screen is not shared. Oh, here it is.
There it is.
How about we do 37.
37. Any, like, it's an interesting number. It's a prime number. Like, why did you choose it? It's
I chose it because it's a prime number.
You did. Okay.
Because every even number will just come to a stop, won't it? When it halves.
Yeah. I'm not sure if every prime number, I don't know if prime numbers are special here. They might be, but I don't know that. So there's 37. And can you tell me?
You could also try doing 9 to see what happens, to compare what happens with primes.
Yeah, okay. I like trying small stuff first. So we're going to
then we should do 9.
Yeah.
There's 15 and there's 9. First we turn it into, we move 4 of them.
Okay. 4.
And then we move the 2, right?
2 move, yeah, that's right.
And now we move 3 and then it's a tie.
And then it's a tie. Okay, so, it's a 3-way tie. I wonder how often that happens. Maybe this is the only time that this ever happens. Because I think multiple ties have got to be pretty rare. Good. So I'm happy to try 15. If you would like to try 15, let's try 15. Again,
okay, 15's the first odd composite after that.
Yeah. So
first we turn it into 7 and 8.
Okay, so let's do that. So here's 5, 6, 7. We'll drag that over.
And now we turn. And now we move 4 from the 8 over to the 7.
Okay. Got it.
And now we take, now we've got an 11, so we have to move 5 of them.
Okay, let's move 5. Got it. 1, 2, 3, 4, 5 over to here. And it's just getting a bit messy, so let me just clean it up. There we go.
And then have the sticks into 3 and 3.
Sure. Okay.
It seems like this is a very long one. And on the next step, we'll have the 8, which makes us have 4 urns in it already.
Oh, so for the first time, I don't think we've got to 4 urns before. Oh, yeah, we did. We did get to 4 urns before.
But now it's a tie, isn't it?
Yeah, so now it's a
It's
tie.
another three-way tie.
4, 3, 4, 4. Yep. Super Kitty Cat, would you like to choose a number that you think is going to get to 6 urns before any other number? Okay, Colin, go ahead.
27.
27.
That's another odd composite, isn't it?
Yeah.
Yes, I'm curious to see if it'll make a 4-way tie because it's 3 times more than 9.
Okay, and let's go like that. So just confirming that is 27. And so
I noticed that a lot of numbers make 3-way ties and not many make 2-way ties, haven't you? That's interesting, isn't it? Don't know why. Maybe it's because there are multiple. Maybe it's below maybe it's like below is multiple or something like that that determines how many ways the tie gets it into.
While
Like
I was
all
away,
numbers
I
will lead to a 2-way tie, and if they're of course a multiple of 2. So
I think I found an answer while I was away.
okay, so I'm just going to finish off. Seth, you should go and look for some patterns, and I'll talk with you in like 5 minutes. Look for some more patterns, general patterns, and you can, of course, you can ask for 7. What's the first number that populates 7 urns? So there's all sorts of questions that you can ask, and you can even come up with questions, and that would also be a good way for you to think. So right now we have the 27 split into 14 and 13. And then I guess this 14 is going to split again. So this is Colin's challenge to us. So there's the 7. And I better write this down because now I'm starting to lose track here. So this is
7 and 20.
Less, and that's 20. Right. Okay, I'm just going to clean it up a little bit. Right. Okay. So there we go. And okay, that's just going to be 10. Oh, so that ends really quickly. Yeah, it's surprising that some of them end just like they're gone. Boom, they're finished. Like 13 lasted a lot longer than that. Was it 13 that we started off? Let's see, where was 13? Was it 13 that we did, or 9? So 9 was finished. Oh yeah, 9 was finished pretty quickly. And this was 15. And 15 took a little bit longer. But this one was very fast. We went from 27 to 14 and 13 to 7 and 20 to 7, 10, and 10. So very fast. Right. So Super Kitty Cat, or Aaron and Amelia, or Stick Person, or Colin, you guys are still with me here. So what are your ideas about?
I think I'd figured out, it seems like the answer would be the smallest odd number that you can divide by an odd number that you can divide by an odd number, like so on 6 times.
I think I got a general solution.
Okay, so I'll come to you in just a second, Seth. So Stick Person's idea is that you want an odd number divided by so you kind of want a cascade of odd numbers. So let me just think this through. So what does that mean practically, Stick Person? So for example, 11 is not good because it's 5 and 6, and 6 is an even number. So instead of 11, you actually want 13 because 13 breaks up. Oh no, the bigger one will always be even. But it does seem like it has something to do with maybe.
No, no, 13 breaks up into 6 and 7. The bigger one will be the 7. 7 breaks up into 3
That's
and
right.
4.
Yeah, that's right.
I think that maybe if you're trying to get the longest possible, you might want like 1 over a power of 2, maybe.
Yeah, it's something to be too.
Okay.
I think it's 1 over a power of 2 will give you a really long thing.
Okay, so
I mean,
Oscar,
1 plus
can you go and experiment with one with a power of 2, or it's
I have
1
something
plus
with
a power of 2? And Seth, I'm now going to go to you. Tell me what your observation.
Okay, so basically, I think that I have a general solution. So right now we're using 1, 2, 3, 4, 5, 6. We're using 6 urns, and I think that the answer for this should be 63 because I found that I believe the answer should be the 2 to the power of the number of urns minus 1. So if we had 1 urn, the answer would be 2 to the 1 minus 1. So 2 to the 1 is 2, and then minus 1 is 1. So our answer would be 1 for 1 urn. For 2 urns, it would be 3 because 2 urns is 2 to the 2. And then you do minus 1. So 2 to the 2 is 4. And then you do minus 1 is 3. And your answer would be 3, basically. Yeah.
Okay. So let me just get your answer. So shall we do it for 63? Is that a good place to start, or is that too complicated?
Yeah,
Do you want to start at an easier point than that to explain to people?
Maybe we could do.
I think if you want something longer,
actually, can I share something? So,
65, not 60.
Well, this is how I found my answer. So basically, the smallest number for 1 urn would be 1.
Okay.
Over here, just
oh,
1
I love. Okay, so first of all, I adore you going back to 1. This is good thinking. Okay, so we've got 1. I love this. Now go to 2.
Yeah. So with 2, we want the answer to end up being 1 because that was the smallest for last time. So for 2, we gotta have 3, which is 1 plus 2. That might sound confusing. So it's basically just the last one plus the slightly larger one. If 1 was 1.
Okay, so just let me. So the objective here. So if this then this is going to go over here, and then this is going to go here, and then this is going to go here.
Oh wait.
Okay,
no,
so actually, 3 goes to 3 urns, and to get to 2 urns, I think you just need 2, right?
Okay, my idea is flawed. Never mind.
Yeah, so your pattern might not work, but maybe it just doesn't work for low numbers. Maybe it does work for larger. So let's keep on going.
I don't know. Probably not. Okay. Then I thought, what was next?
Like early on, we did 7, and I think that was
7.
the very first one, and that went like I made a mistake, but that went to 4.
Yeah, I thought 7 would be the next one, and then after that, I thought 15 would be the next one. I'm not entirely sure if that works.
Right, but 15 didn't go well, right? Where was 15? That's 20. Where was 15? Here's 15. So 15 went to here and to here to there, and
So
this was 15. So
not exactly how it worked, I guess.
it didn't go any more than 7, right?
Okay,
7
never
also
mind
got this. So
never mind then. I shall be going away again.
but Seth, I love your idea of using powers of 2, and
I think it was actually based on my idea.
yeah, sure. It's good to have group ideas.
Gord,
That's
Are
why
using
we come
powers
here.
of two.
Yeah. So I think that's a
I'm
good way
trying-
to think. I would like you guys, instead of trying to see the ones that end off quickly as a failure, I want you to think about the ones that end off really quickly as successes. So how can you just have one step and that's it? You guys already know the answer. So
With a two.
Sorry, go ahead. I'm interested in all of the numbers that you just get a single step and then it's finished. Which numbers are true for that?
Gord,
Yeah.
we don't have much time.
Yeah, no, I know that. I know that.
Have, like,
Super Kitty Cat, tell me about which numbers end off really quickly. That you just have one step and then it's finished. If I told you that
I'm not
I'm
not sure.
Okay, if I told you that the number 9,999 ended off in one step, would you believe me?
Probably probably not. I'm not
Yeah,
sure.
no,
Probably not.
Yeah, I don't think that sounds believable. What about a million? Do you think a million's going to end off quickly?
Yes.
Probably not. Or could be. I don't know.
Yeah, it's going to end off quickly. It's going to go
Yeah, it'll
500,000,
just
500,000, and then it's going to be finished. So a million
but
ends
even
off
numbers
immediately.
will end off really quickly, won't they?
Even numbers. Yeah. So exactly right. Now, my challenge to you guys is I want you to tell me which numbers end off in not this quickly, but a little bit slower, but only a little bit slower. I want you to look at numbers that end off in 4 steps.
I'm not sure if you know the solution. Does this have anything to do with Mersenne primes, or am I just going off in the wrong direction?
Experiment.
Okay.
There's low enough Mersenne primes that you should be able to have some kind of idea. If that's a false direction, and absolutely come back to me tomorrow. We only have 2 sessions left, but come back to me tomorrow and tell me if that's working.
Maybe someday you come back once a week, so you still have time to feed your kids.
Yeah. Yeah, I just have to make this my job, so I have to make this work economically. So I because I love this. I love working with you guys. I just need to make it work. So we'll
miss you.
Yeah. Thank you. Aaron, did you were you playing around with anything there?
Well, I've found a brute force solution that actually gets me to 6 urns, but I don't have much insight that goes along with it. I just kept picking odd numbers and trying them out all the way up until I found one.
Right.
So the insight I guess I have right now would be that the smallest number to get to 1 urn is 1. The smallest number to get to 2 urns is 2. The smallest number to get to 3 urns is 5. The smallest number to get to 7 urns ended up being 4. The smallest number to get to 5 urns for me ended up being 31. And if you want, I can tell you what number I used to get to 6 urns.
Well, we'll leave it for. I just thought that you might have had some insights beyond it. Yeah, Colin, go ahead.
You don't want to end up with numbers where you end up with an even number that's big. So if you ended up with something like 16 partway along, or 24, you end up 24 splits up into 12 and 12, and then they're both the biggest number, and then you're done.
Yeah,
that's a quick way to end a pattern like 33, for example, because you get to 17, 16, 9, 24, and then 9, 12, and 12, then that's it.
So I guess I'm now wanting people to focus on numbers that end in 4 steps. The
Okay.
2 steps, okay, yeah, even numbers does it. What numbers end in 4 steps? So that is a really interesting direction for you guys to think in. Colin, I'm going to come to you, and you're going to be the last comment of today.
No, actually, I realized that what I was thinking was actually incorrect.
Oh, that's great, because let's end off on a failure. It's way more fun to end off on a failure than to end off on a success. I love that. Good. So I will see you guys tomorrow, and yeah.
Bye.
Take care, everyone.
Bye.